Hi friends, welcome back to Improve 10x. Today we are going to check the part 2 of inheritance. So let us quickly look at the different topics that we are going to discuss today. So today we are going to discuss about inheritance types, typecasting and instance of in Java. Then we are going to refactor the code that we have completed in our last session that makes our code better. And finally, we are going to implement in the Temple Run game the different kinds of inheritance types we will be learning today. So quickly to recap, inheritance is nothing but a way of acquiring the properties and behaviors of a class. And we already discussed what is a superclass and subclass. Let us discuss the various inheritance types that are supported in OOPS languages in general. So coming to the first one, which is single inheritance. In single inheritance, there is one superclass and one subclass. And the properties of class A are inherited by class B. The next one is multi-level inheritance. In multi-level inheritance, there are more than one levels. So as you can see here, class A is a superclass. Class B is extending from class A. Similarly, there is another class C, which is extending from class B. So there are more than one levels in this particular inheritance type. The next one is hierarchical inheritance, where there are more than one subclasses which are inherited from the same superclass. As you can see in this picture, class B, class C, and class D are all the child classes of class A. The next one is multiple inheritance. Multiple inheritance is the type of inheritance where a single class can have more than one parent. So in this picture, as you can see, class A and class B are parents of class D. The next one is hybrid inheritance. So in hybrid inheritance, it is a combination of both hierarchical inheritance and multiple inheritance. So at level 1, there is one class from which two classes are extending, which is class B and class C. Again, there is another class D whose parents are both class B and class C. Multiple inheritance and hybrid inheritance are both not supported in Java using classes. We have already covered in another video in detail how Java supports multiple inheritance. You can find the link in the description box, as well as we will tag that particular video at the end. Let us go to the next slide. So we have been working on the Temple Run game in our previous example in inheritance part 1. As you can see in this picture, this is how we have implemented single inheritance. There is a player class which is extending from character class. The next kind of inheritance is multi-level inheritance, which we did not implement yet, and today we are going to implement the same. So here there are more than one levels. We already implemented character and player classes, right? So now we are going to have a powerful player, which is extending from the player class. Generally, in most of the games, when a player collects a coin which is of a higher value, let's say a value with 1000, then this player will attain some special powers. So that particular scenario we are going to mimic in our code, and we are calling that class as powerful player. So here powerful player is extending from the player class. This is how we support multi-level inheritance. The next one is hierarchical inheritance. This we have already implemented in our game. So the parent class is obstacle, and there are three child classes which are fireball, spike pit, and point, that are extending from obstacle class. Coming to typecasting and instance of. We have discussed is a relationship in the last video. So if you can see in this picture, we can say that player is a character. Similarly, powerful player is also a player. So we can create an instance of the player and assign it to character class reference. Similarly, we can assign powerful player instance to player or character reference. So we can create a player reference and assign any child class object at runtime. In this case, we want to check if it is player or powerful player object that we are assigning to the player reference. For that, we can use instance of keyword in Java. However, using player reference, we can access only player class members, that is methods. If we want to access powerful player members, we have to do explicit typecasting so that we can cast this player object into powerful player object and accordingly access all the members or the methods of that class. Similarly, we can create a reference of obstacle class and we can assign either fireball instance, spike pit instance, or coin instance. At the same time, we can also check using instance of keyword whether we are assigning the right object in order to call the available methods in that particular class. Now, let's go ahead and refactor our existing code in order to implement instance of and typecasting and also to make the code better. After refactoring is done, we can continue with implementation of various inheritance types that we have learned today. In the previous video, we have implemented Temple Run game using inheritance concepts. So today we are going to continue implementing the different types of inheritance types. But before that, let us clean up our code as well. So this is the point where we have stopped last time. We will go if any cleanup is needed step by step. And we are also going to use the concepts that we have learned today, like typecasting and instance of. So let us start with character class. I am kind of removing the methods that are not used. For example, set name and set health. And these are also part of the clean code principles. Whatever we are not using, exposing them or giving access to the outside world is very risky. It is a security concern. So that is the reason we are removing set health method as well. Okay, everything else looks fine. Let us go to the coin class. Coin class has only the methods and variables that are needed. So we are going to continue with the next class, which is obstacle, which is the parent of all the obstacle classes. So here also we have just the constructor and the collide method. So no refactoring is needed as of now. Let us go to the spike pit class. Spike pit also, if we check, the members are already private and this is also fine. Let us go back to the fireball class. Yeah, this also looks fine. There is not much refactoring that is needed. Now let's go back to the player class. As we are not using jump, I'm just removing this particular method. Finally, let's go to the Temple Run game. So as you can see in this main method, the method is very lengthy. So let us try and see if we can refactor it. And how are we going to refactor it? So first of all, there is a lot of the functionality that is happening in the obstacle type and how we are calling the different methods based on the obstacle type. So what we are going to do is, let me refactor this by generating an obstacle directly. So what I'm going to do is, I'll create an object of obstacle class and I'm going to write a method generate random obstacle. So this is going to give us an object of obstacle data type. So I'm going to create this method here itself. Done. Okay, by default the return is null. Okay, once we have the generate random obstacle method, let us start with the refactoring. So the first thing that we need is a random class object. So I'm going to take this random class object and paste it here. Once we have the random object, then I can generate a random number. So this is where I will try to take the obstacle type so that a random obstacle type is generated. Here I'm going to use the switch case where I'm going to make a decision based on the obstacle type. So the first one is case 1, which is when the obstacle type is 1, we need to create an instance of a fireball, right? So I'm going to take this part of the code, and from this generate random obstacle, we are expecting an obstacle type as a return type. So I'm going to return the same. Once this is done, once a fireball obstacle is returned, here in this particular area, the change that we are going to make is I'm going to check if whatever obstacle has been returned from the generate random obstacle method is instance of fireball, because that is what we are expecting. So once we have a fireball instance, then this is already done, so we can simply remove this line of code, and I am going to replace this fireball with obstacle object. So as you can see here, obstacle.collide is not showing any compiler error because in the obstacle class, we already have a collide method available. Here, if you see, the obstacle is a reference of obstacle class, but we are assigning a fireball class object here. That is the reason here we are getting a compilation error in line number 17. So in order to access the role method, which is in the fireball class, the obstacle object must be typecasted to the fireball object. So for that reason, what we are going to do is, let me typecast to fireball data type, and once this is done, the role method should be available for this object. So this is nothing but typecasting. And here we are also checking if this obstacle is instance of fireball, only then we are allowing this operation, which is allowing role and the collide. Okay, this is done. Next, we are going to continue with case 2. So what is going to be case 2? If the random integer is 2, then in that case, we need to return an object of spike bit. So let me just copy paste from our previous code. So I'm going to return this spike bit object. And once we get the spike bit object from here, this time I am going to check if this obstacle object is of type spike bit using the instance of keyword. And once that is done, this line is not needed anymore. And using the same obstacle object, I wanted to call the trap method. So here, as you can see, there's a compilation error. So let me cast this into spikebit class. Done. Next. So the default case would be when we want to return a coin object. So I am putting that under default, and this time I am returning new coin. But in order to return this new coin, there are multiple things that we need in this default block. So I'm going to create a block here, and I am going to return the coin object. But before that, we need a random index value as well as coin values array as well. So I'm going to simply copy those coin values array here. And once we have the coin values, I am going to select a random index value, again using the random object that we have. Okay, done. Yes, now we have returned a coin as well. And once this is done, we can simply delete all these lines, and player.collect coin. So coin is nothing but now it is obstacle. So let us go ahead and also check if the obstacle that is returned is of coin type. And once that is done, we are just going to collect that obstacle. However, a typecasting is needed, so I'm typecasting it into coin data type. And here we do not need any return null because from every branch we are returning a single obstacle object. And whatever code is unnecessary, the variables that are not needed can simply be removed. So the coin values int array can be removed in the main method. Similarly, random object is also being used only in generate random obstacle method. That is the reason we can remove from here completely. Now, once this is done, we have two methods, which is the main as well as generate random obstacle. Now we are going to do a little more refactoring by taking whole of this obstacle related code, and I will move that, or I will extract that into another method, and I'll name it as handle obstacle. Okay, so let me close this file on the right side. Now here we have, if the game is running, the player will continue running, and the game will also handle the obstacle type. And let us simplify the thread.sleep as well. Since we are just catching the exception and printing the stack trace, what we can do is, instead of, we can eliminate this try catch block here, and I'm going to add the throws clause to the method signature itself. So I'll add it to the main method here, add exception to method signature. Once that is done, I'm going to just clean up the empty lines, etc. And now this is how our code looks like. So the main method has some 12 lines of code approximately. Then we have the handle obstacle method, and then we have generate random obstacle. So these are the changes that we have done. We can consider this as refactoring complete. So now we wanted to see if after all these changes still the application is working properly or not. So let us go ahead and run the application. So guys, if you observe, we have made a lot of changes. We have tested our code, it is running, it is working properly, but we will not be able to tell if it is covering all the edge cases. So this is where TDD will help you a lot. So TDD is not just for writing a simple unit test. It's not like that. The concept of TDD is much bigger than what we think. So it will give you the confidence and it will build a safety net over your code. So to follow TDD, we have made a playlist, which is TDD hands-on. That will be linked in the description box, as well as you can see that at the end of this video. You can go ahead and check that out. So yeah, let's run the application once again and see if everything is working properly. Yes. So this particular adventurer has was trapped in spike pit twice. So his life or his health has reached 0, and the final score is 30 because he collected a coin value of 30, right? So this is how we have completed our cleanup process. Yes, let us go ahead and start implementing the various inheritance types which we have learned today. First of all, let's go and see if we have what inheritance types we have already implemented. Coming to character, this is the superclass of player class. So player is extending from a character class. So this is an example of single inheritance. Similarly, we have an obstacle, and this is the parent class for fireball, spike pit, as well as coin class. So 3 children having the same parent. This is nothing but an example of hierarchical inheritance. The next one that we're going to implement in this project is multi-level inheritance. So we are going to create a new class called powerful player, as we have discussed previously, which is extending from player class. So this is extending player class, and as you can see, there is a compilation error because we need to create a constructor matching super. Done. We need string data type, and we can call it as a special power type. And the special power types in this particular example that we are going to use are super speed. Yeah. Another variable is once we have a special power, it should also be available for a certain duration. So we need an int type, and we can call it as a special power duration. This is the variable name. So let's go ahead and add these in the constructor as well. Let me add special power type, and the one that we get from the parameter, let me assign back to the one in the instance. And whenever we are creating a powerful player object, let us initialize the special power duration to 0. Based on the special power type, let us assign the different durations. The next method that we are going to have is using this special power, right? So let's create a method for that, which says use special power. And in order to use a special power, first of all, the special power type must be available. So we are going to check that it is not null or empty. If special power type is not equal to null, and also it shouldn't be empty. So I'll say not special power type dot is empty. Okay, this should be type. In this particular case, it means that we have some special power. So else, it means that we do not have any special power. So in the else case, let's go ahead and print that this particular character does not have any special power. So I'll say get name does not have any special power. Now, if the character has a special power, we also need to define what is that power. So we are going to check what kind of power it is. So if that special power type dot equals, let me compare it with super speed. This is one of the parts that we were discussing about. Then in that case, I am going to assign this special power duration to 5 seconds or 5 units. Similarly, else if special power type dot equals invisibility, let's say, then in that case, I'm going to set this duration to some 8 units. Let's add a print statement here and say this particular user has gained this special power. And here I will say that this particular person has activated the power for the duration. So I am going to print out the duration. Yeah, I think we are pretty much done with the use special power method. Similarly, we are going to write down the next method. So once we have a special power and we have activated it, we need to reduce its special power, right? For example, if this super speed is available only for 5 time units, then based on the time unit, we have to keep reducing it, and finally we have to make it 0. And once it is 0, then we have to completely set the special power type to null as well. So all that functionality, let us go ahead and write in this particular method. We can call this as reduce special power duration. Special power type is not null, so I'm going ahead and writing that not equal to null. Also, also we need to check if that special power duration is greater than 0. Then what we are going to do, we are going to simply decrement the special power duration. We can also check if that special power type is super speed. So I'll add another logical AND here. So special power type dot equals. So in that case, we are decrementing, else we are going to set the special power type to null. Yeah, and also we are going to write a system.out.println statement which mentions that the power duration is done. We can write that the special power type has ended for this particular user. So this is about reducing the special power. The next method that we have to handle is the run method. You can see in the player class, there is a method called run, and this is for a normal player, right? So we just printed a statement called running. However, if it is a powerful player, in that case, we need to print that he is running at a a speed that is other than normal. So let us go ahead and override this method, and we can also check if the power type, which is a special power type, if that is equal to super speed. And initially, let us check if it is not null. Special power type not equal to null. And if it is super speed, then in that case, let us go ahead and print that they are running at super speed. Else what should we print? We can simply print that particular person is running at normal speed. So I'm just going to copy paste that, is running at normal speed. And now there is no need to call the superclass run method, so I'm just deleting that line of code. Yeah, that's it. We are done with the implementation of run as well. So here, what changes must we make? First of all, a player becomes a powerful player when he collects a coin that is of a greater value. So let's assume in our game, the value of the coin is 1000. So the first step that we are going to do is add a coin value, which is 1000. And for the building purpose, I am removing certain number of coins just to make sure that the number of choices it has are very less, and 1000 gets picked up easily and we can test our game. So I have added only coin values 10, 50 and 1000. Once this is done, in handle obstacle, so whenever it is of coin type, yeah, the obstacle is of coin type, here we need to check if that coin value is 1000, then we have to go ahead and call the use special power method, right? So let us check that if this obstacle dot get value. So for that, get value, if that double equals to 1000, then we consider, or we have to upgrade this player to a powerful player. What I'll do is player is equal to new powerful player, and I'm going to get the name and health from the existing player itself. So I'm going to say player dot get name, comma player dot get health. And the third parameter is the special power type. So I'm going to pass super speed for this parameter. Once this is done, this player, so this player should be able to call this use super speed, use special power method actually. So in order for this player to call, we need to typecast this player into powerful player. We need to typecast the player into powerful player in order to use this method. So use special power. Now he will be able to use the special power. As you can see, we are typecasting this obstacle into coin class at multiple places in line number 29 and also 33. So let us move that into a new line and say, so I'm just creating an object of coin class, calling it coin, and I'm simply going to move this typecasting here. So I'll do it once, and now I can use the coin object wherever it is necessary. Okay, done. Okay, there is a bracket that is missing here. Yeah. Okay, so we have collected coins also. So we will move this statement here above. Done. Now, once he uses, he gets the coin value of 1000, he can use the special power. We have another method in powerful player class, which is reduce special power duration. So that can be called whenever the powerful player has a superpower, but once he attains that power, it has to reduce second on second. So what we're going to check in this is, we'll write an else if, and we will say that if this player is an instance of powerful player, then that is when we are going to call this particular method, reduce special power duration. Done. Okay, let us run once again so that we make sure that the coin 1000 is picked. Wow, that's great. So as you can see here, so as we have seen the output, there are some parts that are missing, and the reason is that, so here we are assigning a new powerful player object to this reference, but this is not being affected when we go back in line number 11. So that is the reason. Let us go back and change the return type of this player and finally return player, and using this player object, let's call the player.run method. Yeah, let us go ahead and rerun the game again. Okay, we are waiting for it to collect a coin value of 1000. Okay, yes. So this time it collected a coin value of 1000. So the overall score must be 1010, but it is 0. So there is some issue here. Let us go ahead and see what is happening. So when the player is getting upgraded to powerful player, we are creating a new object, and here there is a super constructor that's being called, but we are reinitializing the score to 0 every time. So in order to fix this, what we will do is, instead of passing individually the player health and name, let us pass the player object itself here. So I am modifying the constructor so that it will accept the player object along with the special power type. Actually, let us use get name and get elf. We have a get score, right? So I will generate a setter for this. Okay, done. Once we have created the sets for method in a player, let us go ahead and call that, and let's pass player dot get score. So this is going to set the score for us. Now let's go ahead and test it. Right, as you can see, now first initially a coin value of 1000 was collected, and super speed upgraded to powerful player, and after that there's a fireball that's collected again. He collected a coin value 10, so the overall score is 1010, and yeah, the game is over. So guys, as you can see here, even though the coin of 1000 has been collected, we are unable to see for how long that has been active. So let's go ahead and add a print statement here, which says it is active for another so and so seconds, with each second decremented. Let me rerun. Yeah. So as you can see here, Adventurer has activated the power for 5 duration. Super speed is active for another 4 seconds, another 3. But within that time itself, since the health has reduced to 0, the game is over. So the final score is 10 plus 1000, which is 1010. So this is it, guys, for the implementation part. As you have seen, we have implemented multiple types in Temple Run game, along with the usage of instance of and also explicit typecasting in order to access the methods that are available in the child classes. If you have any queries, you can add a comment. For more interesting videos, you can subscribe to our channel. Thank you.